Hi, my name is Dear Tiagi, and in this video I will be going over the disk and washer methods. So to begin, let's imagine we have a function f of x, like so, and we want to find the area, we want to find the solid revolution from here, let's call this point A, and here, call this point B. And so we want to find the solid revolution, which is again what we get when we rotate this graph around a 360-degree axis about some axis. Let's say we're rotating about this axis. So we rotate here, and if we rotate, we're going to get some kind of shape that looks like something like that. Because again, we're rotating about this axis, like so. So the idea with the disk and washer method is we want to use cylinders, tiny cylinders, to get the total area. So here's the idea. If we have a bunch of cylinders, like so, sorry, I'm not really good at drawing cylinders, but if we have a bunch of them stacked, like so, so again, the area of a cylinder is volume equals pi r squared, and so if we have a ton of those, an infinite amount from here, from A to B, then we're going to get the area of the total solid revolution, no matter what the function is, because we're making a cylinder at each point of the function. So based on this formula, what we have to do is we have to integrate. So the idea is we have a cylinder with width dw, because again we're taking infinite amount of cylinders. The radius of the cylinder is equal to the distance from the axis to the point, which in this case is just f of x. And yes, now we have to do this. We use this formula. So the volume of the solid revolution is the integral, again, from A to B, because we're taking the cylinders from A to B, of, so r squared, so f of x squared dx, and again, we have to have the pi there, like so. And so another way we represent this formula is by saying volume is equal to the pi times the integral from A to B of r, big R, x squared dx. And big R just stands for the distance from the function that you're integrating, or you're finding the revolution of, to the axis of rotation, or sorry, the line of rotation. So let's try an example. Let's say we have the question. Let's say we have a function bounded like this. We have y equals square root of 2x, and we're bounded by here, this axis, and this axis, we'll call this x equals 2. And we're rotating, so this is rotation, about y equals 0. So in this case, using the formula we had from before, we have to take the volume, so this is the revolution, so we take the pi times the integral from A to B of r, big Rx, so big R is from here to here, the distance from any point in the function to y equals 0, which is just square root of 2x. So square root of 2x squared dx, which becomes pi integral from A to B of 2x dx. This ultimately becomes, so not B to A, we're integrating from 0 to 2, because that's our solid revolution, bounds. So it becomes pi x squared from 2 to 0, 0 to 0, and then if we plug in 2, we get our answer, which is 4 pi. And that's how we do a simple solid revolution. Let's say now that we had another function, this one I'll call, just for variety, let's call it square root of x. And let's call this point, let's call it just x equals 3. And we're still going to do it from x equals 0 to x equals 3. But now, let's say instead of the axis rotation being the line y equals 0, let's say the axis rotation was the line y equals -2. So now, we have to change how we find big Rx. So set it up so we have volume equals pi times the integral from 0 to 3 of, so now we find big R of x. So big R, we want to find, again, big R is from the axis of rotation to the function. So the function goes from here to here, so that's square root of x, but the axis of rotation is still 2 down. So what we have to do, we have to add plus 2. By adding plus 2, we get big R of x, which is, again, from here to there. So what we have to do is we have to integrate square root of x plus 2 squared dx. So if we solve for this, we have pi integral from 3 to 0 of x plus 4 root x plus 4 dx. Then we get pi x squared over 2 plus 8/3 x to the 3/2 plus 4x, and then we just plug in 3 and 0. So again, the idea here, we just want to find big R of x and then plug into the formula. Now with the washer method is the same thing, but the idea here is we have a hole in our rotation. So for this one, I'll teach you through an example. Let's say we're trying to find the area, the solid revolution bounded by y equals square root of x and y equals x squared. So this would look like this. So we have the y-axis there. Square root of x would go like this, and then y equals x squared will go like that. And we're taking this bounded area and rotating it about y equals 0. So how would this look like in real life? It would look something like a sphere, but there'd be like a little hole in the middle for this area here. So the idea we do here is now we have, again, a big Rx, and big Rx is, again, the function from the top function to the axis of rotation, but now we also have a little rx, and little rx signifies from the lower function to here. So what we want to do here is we want to take, again, we first take the big Rx, we find the solid revolution there, and we subtract this little Rx, the solid revolution of that, because if we do that, then we'll get just this solid revolution. So the formula is the volume, using the washer method, is the integral from a to b times pi again of r of x squared, big R of x, minus little r of x squared dx. Again, the idea here, take the big one, rotate that, take the small one, and then rotate that and subtract them, because then you'll get just that area there. So for this example, the bounds are from 0. Okay, so the bounds are from 0 to 1 because square root of x equals x squared. This is only true when x equals 0 and 1 because square root of x has to be positive and it's only equal at 0 and 1. So 0 and 1, the bounds are pi times integral of 0 to 1. Big R of x, again, this is square root of x. So square root of x, big R of x, which is square root of x squared, minus little r of x, which is x squared. So x squared squared dx. Integrate that, we go x squared over 2 minus x to the 5th over 5. And then you from 1 to 0. So pi 1/2 minus 1/5, which ultimately equals 3 pi over 10. Again, just to reiterate what I did here, the idea is find big R of x, subtract it from little r of x, rotate, and you get just that using the washer method. Thank you guys all for watching. If you have any questions, be sure to leave a comment down below, and please subscribe for tomorrow's video, and that's it. Thank you guys all for watching, and goodbye.